Hello, everyone. Welcome to our last Teen Teach of the Year. We are the Dreamer Duo, and this is Module 5, Chapter 7, Decimals, Real Numbers, and Proportional Reasoning.
Okay.
Oh, I forgot to introduce myself. I'm Annabeth Hrdlicka, and this is...
I'm Masheka. Hi. I'm trying to find out where to put the screen. I guess right there. Okay. So for our first problem, we have to convert these decimals into a fraction in the lowest term and demonstrate how to find the prime factorization of the denominators of each case. So first, we'll have to find the values of the number, like and what it goes under. And then when we find the value, we have to divide the number by the place value. So I have a question for you, Annabeth. Why does the number have to be over the place value?
Well, while doing anything with fractions and percentages, well, fractions, which turn into percentages, the fraction must have a placeholder under the number. If not, it wouldn't be a fraction. It would be a whole number or another type of number, but not a fraction. So to make it a fraction, it has to have the placeholder, has to have one on top, one on bottom, one in the middle to be a fraction. So that's why you need it. And I have a question for you as well about the placeholder.
Okay.
So where do you look to find out what your placeholder is?
Well, you look at how many decimal places is over to the right, because the first placeholder represents the tens, the second placeholder is the hundreds, and the third is the thousands, and so on. So because we have 3 digits to the right of the decimal, that means we've gone over the thousands placeholder.
Okay, thank you. That makes a lot of sense for sure.
To do the same thing, we for on the right, we do the same as we did to the left, and then divided by the common denominator. And now we just have to find the prime factorization of each denominator. So they both have the thousand in common, so we just have to break this down and the prime factors, and that'll be our answer. So we have 3 2s and 3 5s, and that's the prime factors.
Okay, thank you. Yeah, I see that it goes from 1,000, and then you got to multiply 10 by 100, and then you just keep going. So thank you.
Okay. For this one, we just had to find out the slope formula and then graph the make a graph to represent the slope. So to be honest, any number will do, or any situation. And this one, we said, I said James promised his brother that he'll spend half the amount of time on the computer. So we'll have to just make a graph to represent this. And that's the graph I did, because half of 2 hours would be 1, and so on.
Okay, that looks awesome.
And it's just the same concept for all the rest of the graphs. I have a question for you on this graph though. On this graph, this is different than the previous graph. The previous graph went up and this one goes down. So my question for you is, how do you know which way the slope goes?
Well, you just have to look what is going on in the problem. So if you are subtracting or whatever, dividing, then it's going to go down, it's going to decrease. But if you're adding or multiplying, then it is going to increase. So you just have to remember it like that. So increases up, decreases down.
Right.
So it's pretty simple. Just gotta remember that. And I also have a question for you as well.
Okay.
So my question is, so you see it says that James decides to share half the pins with his brother. So let's say that if the amount of pins were uneven, would you have to round the pins up or round them down?
For this question, pins, you cannot break a pin in half, because to be more realistic. So what you'll do is you'll round down so you'll have an even number that'll be able to be divided equally into it. Just like if you have 2 is a perfect example because you have 2, but you'll have 1, -1, because even though it have a 1 and a 0.05, the realistic way would be 2 and 1 because you'll round down, so it'll be even, if that makes sense.
Okay, that sounds awesome. Thank you. That makes total sense. You cannot just have half a pin, so.
Yeah. Well, thank you. You explained yours wonderfully. And these are the records of the graph that will just go with the problem. Let's go to the next problem. Okay, so this one we have to demonstrate the percentage and fraction of each of the proportions of the figures. And these are our figures we have to go through. So right here, I have a question for you that's very important. We see that this is,
Yes.
Oh, I'm sorry.
I know, I'm sorry.
So we see that the picture is not divided equally, but to solve this, you'll have to divide each of the problems, divide the picture equally. So my question for you is, why do you have to divide it?
So for this one, you have to divide it because if it is not divided equally, then it will either be way too hard to solve or you can't solve it at all. So like if this wasn't divided equally, the bottom number would probably be some outrageous number that would not make sense, or a decimal, and it would just be pretty much impossible to solve or it would take way too much time. So dividing it just helps you a million times more.
Thank you.
And I have a question for you as well.
Yes.
So on that problem, I see that you had to like turn the decimal into a percentage. So how do you know how many places to move the decimal to get the percentage for each number?
Well, I do it as a little trick that I learned in middle school. To get the decimal, to a fraction, you'll have to move it two places to the right. So if your number, like for this problem, you'll have 0.389. So you'll just move the decimal 2 places to the right, and you'll get a 38%, 38.9%, and 38.9 will be your percentage. You just
Thank you.
have to move the decimal 2 places to the right.
And will it always be like that for every single time? Just 2 places, no difference?
Yes. Although
Okay, cool.
if you have a one number, it still works. Like if you have the 7 as a as you're supposed to make a percentage, what you'll do is you'll add a 0, and then you'll still move the 2 decimal, and then that'll be 70% basically.
Okay, thank you. That's a great tip to remember for sure. Just for day-to-day life.
Yeah. And this problem is easy. It's 1/2 because this is places. Let's go to the next one. The next problem, we had to fit each of these shapes into this hexagon and with the percentage, and assign a percentage to the shape. So we already have this solved. My question for you is, how do you, it's hard to find the fraction for the regular square. My question for you is, why is it hard to find the square fraction?
Okay, so as you can see, the square is pretty large. So the square will actually only fit into that hectagon twice, while the other ones will usually fit way more because they're smaller and they're like an easier shape to fit in. So it is so hard because it doesn't fit in the shape evenly. The square, like I said, it can only fit 2 times fully, but any more times it will be overflowing out of the shape. This makes the fraction uneven, and then that makes it even more confusing compared to the other shapes, since it's like doesn't fit as well in there. It's for sure more confusing, and definitely the hardest one out of all of these. So
I think so.
But I have a question for you as well. So that one probably is the hardest one because of how uneven it is. But which one would most easily fit in the hexagon and why?
Well, looking at the shapes, I'll say the easiest one all together would be the trapezoid, because the trapezoid will fit in there twice and it will fit equally. The second one that'll be able to fit would be the triangles, because the triangles, they all divide equally 6 times. So it'll be easier for the trapezoid and the triangle to shape into the hexagon.
Okay, thank you so much.
Okay, let's go to the last question. The last question, I decided to use money because it'll be easier for the money to use money for this. So the first question was, give A and B and what percentage P to B. I said P to B is A. So I use quarters since it'll be easier to use money and we're all used to money. So we'll say a quarter gave her sister 2 quarters. What percentage of quarters did she give her sister? And of course, 50%. And
Yes. The line for sure helps as well to divide.
And the other questions just go as the
I have a question for you. It obtains for part A, B, and C for this question. So, would using other currencies like pennies, dimes, nickels, etc., make this question easier, harder, or about the same difficulty?
Well, for this question, I use quarters because we're used to using quarters with money. But as for pennies and dimes, that'll also be easier because it's just 10% of 100. So I'll say dimes will also be like the next easiest thing, and pennies as well, and then nickels. So the reason money is important is because it's easier and it's something everybody understands. So I think, me personally, I believe that it's easier and it's the same difficulty level because we're just used to quarters. But with dimes, it's just a 10%, but it can still be rounded down or go into a fraction the same, and you'll still get the same answer when it's simplified.
Yeah, quarters are definitely the easiest ones because 25 times 4, $1. So
yeah,
pretty simple.
Out of all the money, quarters is simple because you have 1/4, 2/4, 3/4. It's easier, but yeah. Oh, staple. I do have a question for you
Thank
on this
you.
one as well. For this,
Ma'am, what is it?
oh, I'm sorry. For this one,
Oh, no, it's okay, sorry.
to make minute miles versus minutes. What questions are I? Oh, I skipped the question. My question is, will this still work with more numbers? Sorry.
This problem would still work with more numbers because, like you said, it's just money. So, obviously it goes more than just $1. So it would work with more numbers, but it would get obviously harder with more numbers. And if you start adding, like you said, pennies into the mix and like nickels and dimes, it can get a little more tricky because especially with pennies, it can start making the number really uneven, as in nickels and dimes. And quarters, it's just 25, 10, and 5. So that's still pretty even, but then the pennies can kind of throw you off, but no matter what, you can still solve the problem. It may be a little uneven with pennies or whatever, but money, it's really never uneven. So for this, you can always work with more numbers.
Thank you. That makes sense. You answered that better than I answered mine.
No.
Okay,
You're an amazing teacher.
Question. So this one we have to make a chart. It then have a graph to represent the chart. So my question for you is, to fill in the chart easier, will it be easier to multiply the number of minutes by miles, or will it just be able to just add, which is easier?
It will be easier to just what was the question exactly? Can you repeat it? Sorry.
To fill in the chart, will it be easier to multiply the number by the miles, and will it work for all the other problems like this?
I think it would be easier to multiply it by the numbers because it has a constant rate here, so you can multiply it easier. So 1 mile is 5 minutes. So then if you just, let's say you don't want to solve all that, you could do 4 miles times 5. Since it's a constant, it'll get 20 no matter what. You'll know what's gonna happen. So if it's a constant, then you can. But for other problems, it really just depends if it's a constant or not. But for this specific one, since you know it's a constant, it can go on for 20 more miles.
Oh, thank
So
you.
yeah. And since there's only about 6 points on here, it is definitely easy to just do it the 1 mile, each mile in a row. So you can like show your progress on the graph better if you do it per mile.
Thank you.
Of course. And I have a question for you on this one as well. So in problems like this, should we always make sure to use a constant rate, or should you be cautious of that?
You should be very conscious of this because, and it's better to use a constant rate because it didn't say that the person stopped or it got off track. But it's easier to use a constant rate to see how far it goes. So like for 1 mile, it'll go 5 minutes. It's easier to use a constant rate so we can see exactly how far the person went or how far something is truly. So it's easier to use the constant rate. And it's very important to use the constant rate.
Okay, thank you so much.
Oh, that was quick. Well, I think that's it. Thank you.
Thank you everyone for watching our team teach. We appreciate it. I hope we did well.
I do too.
Thank you.
Bye.